Alright, in this video we're going to take a look at parametric equations, and we'll look at sketching a parametric curve. So, up until now we've primarily looked at functions that define x in terms of y, like y equals 5x plus 2, or y equals x squared plus 6x minus 1, or maybe y in terms of x for inverse functions like x equals 3y plus 8. We also took a look at graphing polar equations as well, and we also, how to convert those to rectangular equations and vice versa. And it turns out what we're going to talk about today with parametric equations is a more generalized way of graphing any kind of function, whether they be x in terms of y, y in terms of x, polar equations, etc. So in this section, we're going to look at parametric functions, which are functions in which x and y, we'll stick with x and y, are defined by a parameter such as t. And a parameter is a new variable that we can use, so x and y can both now be functions of that new variable, that parameter. So for instance, let's say we have a plot of the path a bug might take while walking on a table. So the bug's going to start at point O, and notice on our parametric curve we have these arrows indicating what direction the bug is headed. So the table itself, we can think of it like a coordinate system that has x and y coordinates, and the bug's probably not going to take a typical path that would represent a function of x and y, but in terms of this, the bug might loop and, forgot a parenthesis here after the g of t. At any point on the graph could be have an x and y coordinate where the x coordinate is a function of t, maybe time. T could represent time, but t could represent anything. And y also is a function of t, so I did forget the parentheses afterwards, but it's not the end of the world. So the independent variable, t in this case, we could represent time by t, is called the parameter. If you've ever taken any kind of physics courses, when dealing with trajectory motion, your x and y coordinates on that are usually expressed as maybe a function of time. So the t in that case, representing time, would be a parameter for the path a trajectory takes. So the system of equations where x and y are both functions of t is called a parametrization of the curve. It's not an easy word for me to say. So in other words, your x and y coordinates, each of those values for any point on the graph, any point on the curve, are functions of a different variable, a new variable called t. So note, if we just look at the curve itself, like if you were to graph this in a graphing calculator, it's a set of points, and it's not going to tell you the orientation, the path that the graph took to create itself. So the arrows that were in the path that the bug made while walking on the table, Desmos, for instance, will not tell you the path that it took. It'll just give you the final result. So keep that in mind if you use technology. So we are going to take a look here at example 1, sketching a curve described by x. Each x coordinate is a function of t, where t is the function is t squared minus 3, and each y coordinate is a function of t, where the function is 2t minus 1. And we're going to look at this graph for values of t greater than or equal to -2. And we're going to do this old school method for example 1 and graph it point by point. So what we're going to do is we're going to take values for t. We'll take integer values, but you can really take whatever kind of values you want. And we're going to start with -2 and plug in some integer values in for these equations, and then get a list of ordered pairs that we can then use to plot and sketch our function, or our curve, I should say. So let's start with t is -2, and we plug -2 in for t squared minus 3. We'll get an x coordinate of 1. When we take 2 times -2 minus 1, we'll get a y coordinate of -5. So when t is -2, we have the point 1 comma -5. So we could build this up as we go, but we would start with the point 1, -5 on our x and y coordinate system. going to the next integer, but again, we could have used the next one as t is negative 1.5 or negative 1.8675309. There's no law that says it has to be integer values, but we'll use integers because they're simpler. We plug in a negative 1 for t into each of these functions. We get x is negative 2, and we get y is negative 3, so we have the point negative 2, negative 3 on our graph. When we plug in t as 0, we get 0 squared minus 3 is negative 3 for x. 2 times 0 minus 1 is negative 1 for y. So we have the point negative 3, negative 1 on our curve. And keep going, plugging in 1 for t. When we plug in 1 for t, we'll get x is negative 2. When we plug in a 1 for t, we'll get y is 1. So we have the point negative 2, 1 on our curve. And for t equals 2, we got the point 1, 3. And for t equals 3, we have the point 6, 5. And because there's no upper limit to how far we can go for t, we can progress forever, but having these 6 points should be pretty well enough to get an idea of what this graph looks like. So if we plot these points and then connect them in the order we plot them, we can also put the arrowheads in the graph to describe the orientation as well. And here's what our graph is going to look like. It's going to look like a parabola. So starting with t equals 0, here's our point 1, negative 5. And just as we plot these, maybe sporadically sprinkle in some arrowheads just to show the orientation of the curve. So again, we could keep going forever and ever. It's just going to keep going higher and higher off the screen, but hopefully it should give you a pretty good idea of what to expect. Now, if we plotted this in Desmos, and I do have a video in the Desmos playlist, how to plot parametric curves, Desmos is not going to give you, nor will many other graphing calculator technologies at the time of this video, they won't give you these orientation arrows to tell you which way it's going. They would just give you the curve, and they might even give you some points here and there, but chances are you're just going to see the curve. You won't see the arrowheads, and you won't see these points that are plotted as well, unless you made a separate list to plot the points. So keep that in mind if you're using technology for parametric curves. So, all right, that about does it for this video. Thank you for watching, and I'll see you in the next one.